Newton's law of gravity states that there's a relationship between the gravitational force and the masses of the objects and the distances between them. That's the force of the gravitational force between two objects. That equals the gravitational constant. So this is a universal gravitational constant. Number is 6.67 times 10 to the negative newtons per kilogram squared per meter squared. And we've got two cars parked next to each other in a parking lot. We want to determine what's the gravitational attraction between those two cars. Because remember, gravity is that attractive force between two objects. So that force of that gravitational force is there, and if we want to measure it, we use Newton's law of gravity. And that states that the force of gravity equals the gravitational constant times the mass of the first object times the mass of the second object. So the mass of the first car times the mass of the second car, for example, divided by the distance squared. So this is divided by the distance between the two cars, and then we square that number. We wanted to figure out what was the gravitational attraction between two cars. One car was 1,500 kilograms and one car was 1,000 kilograms. And they were spaced 3 meters apart. We know this number, the mass of the first car. Okay, in this case, it doesn't matter which car is M1, just one of the cars. So one of the cars was 1,500 times the mass of the second car. So that's 1,000 kilograms. Divide that by the distance squared. So the distance between them is 3 meters, and we're going to square that. So that's the first thing you're going to do. First thing, you're going to write down Newton's law of gravity, this equation. Then I'm going to just substitute what I know. So we know this, and this. Here we have it. So now it's just the math. Okay, so what we'll do, we're going to do parentheses first. So we're going to multiply this times this. And when you multiply numbers with these zeros, we're just going to add the zeros up, right? So 15 divided by 3 squared is 9. Multiply these two together. Okay, but let's first just figure out what this is. So this number here is this. Okay, I just took this number divided by this. That then we're multiplying times this number. And then that's going to give us our answer. So how do we do this? We have a number written in scientific notation, and here we have a number that's not in scientific notation. Well, we just are going to multiply this number times this number first. The first thing I do, then I multiply this number times this number. And that gives me this. Okay, and then I'm going to leave this, right? So times 10 to the negative 11. But remember, in scientific notation, this is not scientific notation, so we're going to convert it to scientific notation. Because we can see here, this number should be greater than 1, but less than 10. So we can see this number is way bigger than 10. I'm going to have to move the decimal. So I'm going to have to move the decimal to make this number between 1 and 10. So I'm going to, here's the decimal. I'm going to move 1, 2, 3, 4, 5, 6 places. I had to move it to the left, right? So I'm going to 1.1. And I'm just going to round it to the nearest tenth here. So 1.1 times 10. Now it's not 11 anymore. So I'm going to add 6 to this number, actually. So I add 6 to this, it's a negative 5. So again, just to check it, this is correct scientific notation. So the answer then is 1.1 times 10 to the negative 5th Newton. And that is that amount of gravitational force between those two cars. So if I were to write this out, not using scientific notation, remember, anytime we have a negative exponent, this means the entire number is less than 1. So that means to make this number less than 1, I'm going to have to move the decimal to the left, 5 spaces. So if I take 1.1 and have to move the decimal 5 spaces to the left, this is 1, 2, 3, 4, 5. Okay, so in other words, the answer then is 1, 2, 3, 4, 5. This is the amount of force between those two cars. You can see it's very, 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 very small. This is the 10th, right? 100th, 1,000, 10,000, 100,000. So 1/100,000th of a Newton. And remember, a Newton is a unit of measurement of force. So not Fig Newtons, named after Isaac Newton, famous physicist. And 1 Newton is equal to the amount of force needed to move an object that weighs 1 kilogram and to move it the distance of 1 meter. So the force needed to move a kilogram a meter is 1 Newton. So newtons are units of measurement for forces. And remember, gravity is a force. So this would be the answer for the question about those two cars and the gravitational force between them.